Hello, my name is Yuyatsu. In this video, I'm going to talk about an image classifier model that we built using CNN involving a VGG16 model. So, first of all, we know that digital images, they're made out of a lot of pixels. So, image classification comes in when we try to classify or group those pixels into specific classes. So the reason that CNN is usually a popular choice for image classification because it offers high accuracy. And CNN utilizes or employs a linear mathematical operation known as convolution. So it follows an hierarchical model that provides the machine vision to whether it accepts and then process and output. Output means it classify the images. So in this model, we are going to call one VGG16 model that's pre-trained to perform our image classification. So the reason behind doing this image classifier is that image classification is a crucial part in digital image analysis because we know that each pixel has its own value and is vital in respective fields like maybe medical procedures, navigation. So the thing is, image classification is an important part in digital image analysis because it involves pre-processing of data, detection, object segmentation, feature extraction or reduction, classification, and labeling. So it is an important part. And then I use dog-cat classifier as an example to present this image classification model. So the objectives is to build an image classifier model using the VGG16 architecture and make sure it's capable of distinguishing the images of cats and dogs. Second, we want to calculate the accuracy of loss for both training and validation process. And thirdly, we want to predict label dog cat images accurately when we're testing or predicting. So the data set comes from Kaggle. Kaggle has this online competition to build this image classifier for dogs and cats. So these image represents the folder structure. If you download the dataset from Kaggle, it has training and testing. So training consists of 12,500 images of dogs and 12,500 images of cats, which is 25,000 images. So it does not have a validation folder. So this validation data is achieved by extracting the last 2,500 images of dogs as well as from cats. So there's a total of 5,000 images for validation, 20,000 for training, and then testing consists of 12,500 images as well, but it's a mix. It's a mix of dogs and cat images without labeling. So this is the folder structure once again. We have training and then cats. So these are the label that is being assigned to each image from cat.0.jpg to cat 9999.jpg. So it follows this. Now, the program specification requires an anaconda distribution package to run because the model is built in Python, and this NumPy numerical Python library is quite important for linear algebraic as well as mathematical matrices and arrays, multi-dimensional arrays. We run our model on Jupyter Notebook, which is an online integrated development environment, IDE. So it's convenient. We use this TensorFlow, the deep learning framework, to run our model as well as this Keras. Is this high language library. So we will be importing a lot of functions from Keras. PIL is the Python imaging. So we want to manage our image, we have to use Python, but now it's called Pillow, as well as the VGG16. So VGG16, this is the architecture of VGG16. So these red boxes here are the max pooling layers. So there's 5 of them. The input is set with 224 image input, and the output is softmax output. So these blue boxes here, these are the 3 fully connected or FC layers. So the first 2 of these fully connected layers, they each have 4096 channels. The last one is trained to perform 1000 different types of class prediction. So it recognizes 1000 classes. So we'll be using this architecture. Another reason we want to build this is because this image here sparks kind of internet madness, I would say, because people are confused whether it's a dog or a cat. So this pet, his name is Achum from Canada. He is actually a cat. So after building a model, we'll be testing another image of Achum to see whether the model recognizes as a dog or a cat. So moving on, we are going to demonstrate the code. So at here, I want to import the necessary packages from Keras as well as NumPy. So this is where we set all the library and functions that we'll be using to build our model. Second, we want to set the directory for the training data as well as validation data. So again, it follows the folder structure shown previously, and then it shows that it's found that there's 20,000 images belonging to classes being dog and cat. 5,000, this one refers to the validation data. And then at this point, we want to import the VGG16 model. So it will go to this URL here to download. And then it's being set. The model is trained you at ImageNet. So this parameter is set to true, which means that we want to download all the pre-trained weights for our model. If it's false, then only the weights will be downloaded for the convolutional layer, and the dense layer, they won't be downloaded, for the weights. So we can print the preview of the summary. So each layer is printed here, and take a look at this final layer. This final layer, where's the final? Okay, this final layer here has it recognizes 1,000 classes. Is able to perform the prediction of 1,000 classes, but we don't need that actually. We only need to do 2 types of classification. So the total of 138 million parameters. Another thing is what makes VGG16 so special is that instead of having large number of hyperparameters, it focuses on its convolutional layers, and the spatial padding is preserved throughout the entire model. So we're going to use the first 19 layers as it is without touching. So this layer's trainable parameter we will set to false. False means that we won't be training it and then updating it. Means that it won't be changed. So it just stays the way it is. And then we're going to take out the last layer, and we're gonna replace it with a softmax layer. softmax layer that only want to do 2 unit of classification. And then we update the final model. Now, to compute the loss, we use this cross entropy function, loss function, because cross entropy is the best function for classification cases where the output is from the range of 0 to 1. So in our case, we want to classify dogs and cats. So cats could be 0, dogs could be 1. That's the case. And then we set our learning rate here. 0.0001, and we want to focus on the matrix accuracy. So this matrix will be passed around. Now, since we have changed the last layer here, so we want to print another summary of the model. So we can see that this last layer here has been replaced with a dense layer, and there's 2. So here it performs there's 2 channel to perform 2 classification. Now moving on, this part is where we before training the model, we want to set how do we update it. So there's 2 things: model checkpoint and early stopping. So model checkpoint, it will save the model. By monitoring, this is set to monitor the validation accuracy. So each time the validation accuracy changes, the model will be saved and updated. And then for this part, this stopping is to stop the training by monitoring the validation accuracy as well. But it works with this patience. So patience here means that for 40 epochs, okay, early stopping means that the training will stop if there is no increase in the validation accuracy, but for 40 epochs. So we can tweak this to change it to maybe 20 or 30 depending on our system specification. So right now it's 40 epochs. So if there is no increase in the validation accuracy for 40 epochs, then the training will stop. And then this one is for us to store the training and validation accuracy as well as loss. Okay, so we want to store the information in this variable here, and then we use image data generator to pass the data to the model. So right here you can see that the model is being trained for the first epoch, this step, with a step of 2. Validation step 1, steps per epoch is 2 here. So you can see that initially the loss is like this: accuracy, validation loss, validation accuracy, and then the second epoch it rises to it rises to 0.9 something. So it's being updated from 0.62 here to 0.9 here. So it's being updated and updated until it says that validation accuracy does not increase. So I guess from second epoch, from the 4th epoch here, it doesn't increase. So we're expecting that it will stop at around 44 epoch, I guess. No. Okay, so it stops here, which means that at this point, this is the 40th epoch where the validation accuracy did not change. So it just says, okay, did not improve, and stop learning. So you can see that the accuracy is at maximum of 1. This model employs the transfer learning, which in a good way, it saves computing time. So before moving any further, we want to save our final model as this. And to visualize our training and validation accuracy and loss, we do that. So we just plot all these and we get a graph like this. So blue and yellow represents the accuracy, and then green and red represents loss. So initially the loss could be quite high, and at the 10 epoch, you can see that it's dropped, just keeps dropping. And the training and validation loss as well as accuracy, they are quite close together, you can see. And this is a pretty good model because the accuracy is quite high and the loss is gradually dropping as the epoch increases. So it has a very small loss but very high accuracy. Then moving on, we want to do testing, or we can call it prediction. So this cell number 12 and 13 here, we will be doing the prediction. So we want to load the model here. And then since I mentioned there's 12,500 images in the testing folder, they are randomly mixed images of dogs and cats. So what we're going to do is we're going to set the range over here. This is the start image, like 1 means the first image, this is the end, so the 50th image. So this will cause 50 images to be loaded and with a step of 1. So moving on, here we set that, so 0 is cat and 1 this is dog. So as a result, remember Achum, the dog or cat, is a cat. This is another image of Achum and it's being labeled as cat after the model is being trained. And we can just keep scrolling, so you can see a dog, 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 cat, 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 and so on and so forth. So we can change this as a new start and a new end, so that we can load a new set of images to be tested, as long as it doesn't exceed this 12,500 mark. So that's all for the dog-cat image classifier model. Thank you.